You've made it through the day. Can we please get a round of applause for all the speakers? Fantastic sessions, um, as well as the organizing team, Bell, Seth, Mallory, everyone else at ISCB. Before I get started, Cam, at Alafia, we started Alafia with a single focus of accelerating scientific discovery. But before I get started, I'm very aware that I am between you and the beer hall. So the likelihood of you buying me a beer after this is probably inversely proportional to the time I spend on stage. So I'll get through the slides quickly, and we can obviously chat some more right after this. I personally spent a whole career building systems to accelerate robotics, to accelerate autonomous vehicles, and we ended up building a technology that became very popular among medical imaging researchers. That's what led us to building this company and product that we're partnering with ISCB to showcase around the world. So, what we've learned through some of our customers is the interest that bioinformaticians have had in our product, and they're very excited because it can accelerate a number of their workflows. We are now just starting to work on some genomics projects. That's what led me to come here and learn about genomics. I don't pretend to know anything about the sciences, but I know how to make the most powerful computers in the world. So if I can understand how to translate the language of your problem into a computational structure, I can likely make the most powerful computer that we have ever seen for this. And our vision in the fullness of time is to actually create computing architectures that map to omics problems. But what we have started is first building systems that take the state-of-the-art computational power that you can get, the most amount of power you can get, and we put it for one person to use at a single time. So, obviously, I don't have to tell you this. Your data sets continue to increase. It's very hard to get the algorithms working properly. There's always patient, in the domain that you're participating. There's always privacy regulations and concerns and compliance needs. So, we believe that bringing high-performance computing elements, supercomputing elements, making them more accessible to you will help accelerate a lot of the challenges that you're facing. So what we've done is essentially we've built the most powerful computer in the world. We've taken a processor that was designed to have hundreds of users in the clouds, and we put it for one person to use. And then we've architected memory and the GPU accelerators around that processor to single-handedly give the most compute performance throughput real time. And that is the system that you see there. The problem that we believe we're solving is that a lot of research today in bioinformatics doesn't make it to the patient or to the even before the patient doesn't make it to the doctor desk side, right? Maybe 2 or 3% of the research ends up being a clinical implementation. So we believe that we can create a platform where you can develop the applications in the same system that application is being developed. We can deploy it to a doctor's desk side and accelerate the adoption of your research. So ultimately, think of it, like the Apple, like the App Store for healthcare. So if you make an application that can be validated, can be verified, we can ultimately deploy it together in the same platform. That's what we've seen a number of our customers in use cases, like in digital pathology. We have accelerated a number of those workflows. I don't know how familiar you might be with that. Pathologists traditionally would take a blood sample or a tissue sample. That doesn't happen anymore. They would look at it under a microscope. That doesn't happen anymore. That gets scanned by a big scanner, multi-million-dollar machine that gives you a big image. And to run segmentation algorithms, to run classification algorithms takes quite a bit of compute. So we have a number of customers in that use case, accelerating pathology applications. We've worked with a number of neurology researchers doing cortical reconstruction. These are use cases where we take a few hundred fMRI images or MR images, and then they're ran through a reconstruction algorithm to create a 3D mesh of the brain. That's typically very computationally intensive. Typically, you could do 1 or 2 subjects at a time in 24 hours. In our system, you can do hundreds. And the last use case that I'll show is a lot of molecular visualization, molecular dynamic use cases, because we do have a beautiful screen that can provide interactivity. And then the last thing I'll show I'll show a teaser video of our system. And I don't know if we have audio here for this one, Seth, but you can always ask me more afterwards, and we can have a conversation. No audio in this one, is it? It's supposed to have a very nice soundtrack, actually, but if you go to our website, you'll see it. It's on YouTube, and you'll get to listen to the soundtrack. Well, that's about it. I hope to see you all down at the beer hall, and we can chat some more.